Good evening and welcome to Law Talk. Tonight, we have three subjects rolled into one for your entertainment. Myself, James Barrett, and Mark Malakowski are looking forward to Mr. Emerson Stafford, who's going to present space treaties, space real estate, and an assortment of entertainment for your viewing tonight. Mr. Mark, tell me what's up.
Okay, well, we have Emerson Stafford, who ran the Emerson Bar Review for 35 years and also was a research scientist. And we started talking a few months ago about the subject of space law and what's going on there because, you know, people are going to go out in space and there's going to be things happening. So tonight we want to talk about space treaties, space junk, and also commercial uses for space. So Emerson, why don't you lead off and talk about space law a little bit?
Sure. The two things that I would tell you about space law are space junk and commercial use of space. Now, space junk is junk that's up there that doesn't work anymore. Usually about 8,000 satellites up there, 6,500 of which are dead, and about 1,500 or so satellites which are working. And so there's a lot of space junk up there. And when that space junk comes down, it can injure people on the ground. And while it's up there, it can crash into other satellites. And the space law issue becomes who's liable in those cases.
Now, there's also some smaller pieces they can't track by radar so much, or that aren't actually space junk, but there's some small, like 27,000 smaller pieces?
Well, that's absolutely correct, but we call them all space junk.
Okay.
And there are big pieces, like every time you put a satellite up, there's a piece of space junk that is up there at the same time. And that piece of space junk, when you fire the satellite, when you put a satellite up, in principle, it goes up to a certain altitude and then goes horizontal. It's got to go horizontal fast enough to stay in orbit. And the booster that gets it going fast enough is left up there. And so what are you going to do? So you end up with two pieces in orbit. You have the payload and you have the rocket booster. And that booster is either going to come down or it's going to stay up there a long time and eventually come down. It may crash into other things while it's up there. And the legal problem that we're concerned with is who's liable
Now,
when that happens.
I've got a question, and you looked into this and you studied it, you tried to explain it to me. I'm not sure I really understood it, but there were certain orbital planes. It could be a polar orbital or equatorial orbital. Why don't you explain how those are used to kind of keep things segregated?
Yeah, when you put a satellite into orbit, first let's imagine that you have the Earth, and the Earth is here in a sphere and it's rotating. And so there's an equator, and so the Earth rotates, and if you extend the equatorial plane out so that you have a whole plane instead of just the equator, that's called the equatorial plane. And there are a lot of satellites there in or near the equatorial plane because you can get a very broad view of a cover of the Earth when you broadcast things from the equatorial plane. So there are hundreds of satellites that are in the equatorial plane a few hundred miles above the Earth in low Earth satellite. And there are more satellites in another orbit called the Middle Earth satellite, Middle Earth orbit, and then the high Earth orbits are the ones above that. Now, most satellites that we're concerned with are in low Earth orbit, except a few. And the ones that are in low Earth orbit, many of them are in the equatorial orbit. And if you imagine, just to have a clear picture, if you have the Earth turning around, and if you can imagine a stick sticking out from the center of the Earth, out past the surface of the Earth, and up to like 25,000 feet, just this spoke going up here, and at the equator. And as the Earth rotates, then the spoke, whatever's at the end of that spoke is keeping up with the Earth. Well, we don't really have a spoke, of course, but we put satellites in those locations, and those satellites are moving very fast, like 20,000 miles an hour or so. And if those satellites, so when you put it up, it goes up and then you shoot it forward fast enough so it stays in orbit. Now, what happens is that if the satellite, well, let's back up for a second. What we're talking about is liability for injuries which are caused by satellites, either putting them up or while they're up there.
Now, let's say, when we were kids, we played dodgeball. So if
Yes.
you're a space station up there and satellites coming towards you, don't you have to kind of dodge it? And how would you do that?
Well, let's back up for a second. Let's understand how the satellites are in orbit around the Earth, because that's important for our image of what's going on. So you have the Earth rotating, and at the equator, at the equatorial plane, you've got a bunch of satellites in the equatorial plane that, from a person sitting on Earth looking up at them, those satellites would appear to be just plain old stationary.
Right.
You can also move them around if you want to, but there are a lot of stationary satellites there for obvious reasons. Now that plane, that equatorial plane, if you want to, you can tilt that plane up so that the satellite, instead of being at the equator, it's going around the Earth at the north and south poles. So the satellite goes over the North Pole, goes around, back around the South Pole, over the North Pole, South Pole. So that forms a plane also. Now, but that plane is inclined from the equatorial plane up to about 90 degrees or so. Now, so you can see that if you have a satellite that's going around the Earth from the North Pole to the South Pole, to the North Pole to the South Pole, a couple hundred miles or so up, 500 miles up, and it's going around, that you have, in effect, the Earth is rotating underneath this satellite that's rotating. And if the satellite goes around once every hour and a half, then, and the Earth is rotating, then you can see that if you have spy equipment on that satellite, you can take pictures of what's on the ground, and every hour and a half, the Earth moves a little bit under the satellite. You can get a complete picture of what's going on.
Well, that's like the Google Earth theory when you use Google satellites and you want to find an address, and you can look and you can see right down on it. But these are far more sophisticated. And in fact, when you have the Earth around the equatorial plane and going from north to south, you're effectively covering all the little square inches of the Earth. And that's why people have been so afraid of more and more satellites being launched up there that are not even described why they're being launched up there. And it becomes, the whole planet just becomes one little petri dish for all the satellites to take pictures or to do research or to do spying or to do any number of things.
What you describe is now considered becoming a serious problem, because you can paint yourself into the corner and where you got no way out. And in effect, we're beginning to do that. With about 8,000 satellites that have been put up since we started putting them up, but these satellites in orbit, they crash into each other, and when two satellites crash into each other, what used to be two pieces is now 2,000 pieces. And so they're like 25 to 30,000 pieces of either satellites or little pieces of them that are being tracked by radar, by the Air Force tracks them, and also the European Space Agency tracks them. And you need to do that because you need to know where those pieces of space junk are, because when you put satellites up there,
New launches.
launches.
You got to be able to identify what's in your path as you're putting up the new satellite. But that goes right to one thing that you started with, the liability about what is going on with all these piles of space junk that are going around the planet, maybe coming down, interfering with other satellites. And my question to you is, isn't there like a universal rule that if you put it up there, that's your fault, or do they just lose track of all the junk?
You're close. You're right on track. The rule is that it's a United Nations treaty. There are two treaties that really apply to this sort of thing. One is a 1967 treaty called the Outer Space Treaty, and another one is a 1972 treaty called the Liability Convention Treaty. Now, the 1967 treaty, the Outer Space Treaty, is like the granddaddy, so to speak, of all treaties because it happened during the Cold War is when they put that up there. And the reason so many countries, like 119 countries, agreed to this Outer Space Treaty, and I'll tell you what the critical parts in just a minute, but the reason they agreed is because Sputnik had gone up in 1957, and the Cold War was on, and we knew how to shoot ballistic missiles at each other. And now each side, the U.S. and Russia, was afraid that the other side was going to put ballistic missiles in space.
Right.
Instead of shooting them ground to ground, it's going to be space to ground.
Right above you.
Exactly, exactly. And so the people agreed to the 1967 treaty to prevent that sort of thing. And it has a number of provisions, but the four provisions that stand out the most, that are most important for our purposes are, number one, that and there are 119 countries that have signed this treaty. Number one, no country can claim sovereignty over any celestial body. Okay. Number two, space can be used for peaceful purposes only. Number three, no nuclear weapons in space. And number four, no weapons of mass destruction in space.
Did China sign that treaty?
Yes.
Okay.
Yeah.
So we're hoping that the world powers, as they're being reorganized right now, are going to abide by that treaty.
Well, what has happened is that treaty has been in effect so long that people have come to respect it a lot, and it's kind of like the Magna Carta of treaties. And no one has violated it yet, and no one wants to be the first
That we know of?
That we know of, right.
And so the 1972 treaty is the one that says the country that launched the satellite is liable for if it crashes or hits somebody else or
That's right.
hits the ground.
Right.
And there's some, not so much anymore, there's 30 nuclear-powered satellites up there now, but most of them are being solar-powered at this time.
Yeah, the 1972 treaty does exactly what you said. It provides that if the country from where the satellite was launched is strictly liable for any harm caused on the ground or in airplanes flying in air, but not space stuff. So the country from where the satellite is being launched is strictly liable for any harm caused on the ground or airplanes, and if the satellite that they launch crashes into other satellites in space, then it's a question of who's at fault. Where it's the ground is no fault; it's strict liability.
Okay.
And we have some good examples of that. We have at least one where one country launched a satellite and it contaminated another country. Probably the best example of that is a spy satellite that was launched by the Russians, and at the height of the Cold War. The Russians launched a satellite, and the spy satellites. The way if you launch a spy satellite and it has a polar orbit going north to south to north, and the Earth is rotating underneath the polar orbits, you obviously can get lots of radar, lots of good pictures of what was going on. Well, this spy satellite called Cosmos 954, its purpose was to monitor seagoing vessels and submarines. And the inclination of this satellite wasn't the polar orbit, it was at 65 degrees. But that's enough so that as the Earth turns under it, it eventually gets pictures of all the Earth. So they launched this spy satellite, and it had a nuclear reactor on board. And the reason it had a nuclear reactor on board is because they expected this satellite to be up for a long time, and they needed a source of power for a long time, so they used a nuclear reactor. Nobody does that anymore. In fact, there are still some nuclear reactors going around up there. There are 30 of them up there. And Russia, we launched one, and the Russians launched the other 29.
Were there any plans to decommission these nuclear satellites, or are we just going to leave them until hopefully they burn up in the atmosphere?
The latter, they're left forever.
They're left forever.
Yes, there's no way to decommission them that I know of. I mean, decommission them, they're not in use anymore, most of them. But there's no way to, control the radioactivity, and to deorbit them, you'd have to go up and do something about it. They will eventually deorbit, but hopefully a long time from now.
What about commercial uses? Can we move on to commercial uses?
Well, the commercial uses of space are primarily space tourism and space mining.
Yeah.
And the space mining is obviously people are going to try to mine stuff on the far, particularly on the moon or other celestial bodies. You run into kind of a problem there because the space treaty said you can't own any, you can't, no country can claim any ownership of any celestial body. Well, if you can't own something, how can you mine it and keep the stuff that you're taking off?
That's the obvious question.
That's the obvious question. So the Treaty of 1967 says you can't own any celestial body,
Right.
no sovereignty over it, and yet people obviously want to mine these celestial bodies. So every country really is going to deal with that in some sort of way. What the U.S. did about that is that in 2015 we passed a statute. It's called something like the Space Competition Convention or something close to that. It basically that what it says is if you mine something on a celestial body in space, you can keep it. And the treaty says you can't, we have no sovereignty there. So how do you have the right to tell
Wait a
people
minute,
that?
this sounds like a rewrite of the 1967 treaty, where now they're kind of expanding what does that mean to have ownership of a celestial body?
Yeah, the 1967 treaty says no one can claim sovereignty over a celestial body. And if you can't claim sovereignty, how can you give your people permission to mine?
Well, you can't. Unless
What they do.
That's why you would almost need a United Nations treaty of some sort.
This is the
not
United
just-
Nations.
And that was the United Nations.
These
thing.
are all United Nations
okay,
treaties,
because
But isn't the one you can keep what you mine? Isn't that U.S. statute?
that's a statute.
Yeah, that's not
right. The
UN.
1972 or the 1967 Outer Space Treaty
Right.
says you can't.
That was international.
You can't own it, but our 2015 statute says you can mine it
And you
keep
can
what you
own
mine.
a little of it.
Well, you're not only. It's going to be a conflict. It just hasn't been worked
Right.
out. Other countries did the same thing. Luxembourg passed a law soon after this that said that that if we mine stuff, you can keep what you mine.
Right.
So there's several countries now that say if you find a satellite and you mine it, you can keep what you mine, even though you have no sovereignty over it.
Well,
So
wait a
isn't-
minute.
isn't there
Isn't
some-
this, I'm sorry, Mark. Isn't this like finding a sunken ship with doubloons on it? And it's the same concept. If you're anywhere near a country that can claim it, even if the country has no ownership. So now we're taking that concept to the moon and other celestial bodies?
Well, in a way, but the way this happened is that when the 1967 Outer Space Treaty was passed, no one was thinking about occupying and mining moons at that time. And so the language got a little loose because of that. But now everybody's thinking about it. And so we have a situation where a provision in the 67 treaty, nobody wants to abide by it. And so there's going to be some changes.
And so what
we don't
about-
know what's going to happen.
What is it? Helium-3 on the moon? Is there some possibility?
There's a lot of stuff on the moon that people want to mine. It's helium-3 in particular. There's
and that's for fusion. When they figure out-
aluminum, magnesium, manganese. There's even a little bit of gold. Lots of hydrogen, oxygen, silicon, H3 in particular, because if we ever get fusion reaction working on the Earth, that H3 is an important component of that. You can make it work more functional if you've got H3, and you can get H3 from the stuff on the far side of the moon. So that we're going to mine it if we have fusion here. Even without fusion reaction here, there's all sorts of other stuff that we want. The problem is that it's far away, and only a few of those things are worth bringing back or using there. But there will be space mining. In fact, there's a rumor, I haven't seen anything official about this, but there's a rumor that when Elon Musk goes to Mars, that on the way back, he's going to drop off some astral mining equipment along the way, so he can mine celestial bodies if he can find them.
Now, what about tourism? Space tourism.
Tourism is going to be apparently going to be a big deal. Space tourism. The space station that we have up there now has been occupied for about 20 years or so, and it's going to come down. They're going to decommission it sometime between now and 2030, and just because there's so much stuff going wrong and the solar panels are getting punctured a lot and so forth, and so it's going to come down. It's going to get replaced, and when it's replaced by people doing research up there, these people need a place to live, and we know how to live in space now because we've been doing it for 20 years. And so the Hilton Hotel chain, along with the Orbital Assembly Corporation, apparently are going to work together to provide living quarters for the people there who are doing work. And the plan is to just keep building these, keep assembling and assemble rooms, hotel rooms there in space.
Like Legos.
Yeah, like Legos, only these are, the Orbital Assembly Corporation had a lot to do with assembling the space station that's there now. So these people know a lot about how to assemble stuff in space. And they plan to just keep on assembling and assemble some hotel rooms and to rent them. And this is your tourism that you were talking about. And to get up to the rooms, the space station would be about 150 to 200 miles above the Earth, maybe a little bit more. But you got to get up there. And Elon Musk, with his SpaceX, apparently can get people up there and back for about $3 million. And the hotel people say you can stay at the hotel for about $125,000 to $150,000 per night at the hotel. And so they're expecting that, they were expecting originally to have something to start renting rooms in 2027, but then the pandemic happened and people's schedules got kind of changed. But right now, the space station that's up there is coming down by 2030. I don't know if it's going to come down. They're going to decommission it. They might leave it up there as a museum or something for a while. But otherwise, it's going to come down and get burned up.
Well, then who's going to take that step?
And the Hilton,
Is it going to be Hilton?
Hilton is participating with the Orbital Assembly Corporation to design the spaces for people to live in, including the working people who are there. And the plan is to just continue to expand this till you get, they're talking about 200 rooms in a hotel for people to, and they're getting reservations now. They're $3 million round trip to get up there and back, and about $125,000, $150,000 a night.
Does that include breakfast?
I didn't ask. I should have. Anyway, so space tourism is on its way. It's going to be here. It won't be here on the schedule they had planned. They had planned to start occupying by 2027. That's not going to happen, but maybe 2030, right in there somewhere.
And aren't they going to be trying to do some things to give it a little gravity?
Yes, they are. The people who are in the space station up there now basically have no gravity, but they're going to. The plans now are to put this space station that we're talking about on a large wheel that may be as wide as a football field, and have it rotate, a rotating wheel, so that out at the circumference of the wheel you've got some artificial gravity.
Oh.
And not as much as the Earth's gravity. They're thinking something like a 0.1 of the Earth's gravity will be enough to give people some sense of gravity.
We've seen that in a lot of science fiction movies where they have the big wheel turning and people are actually living in what appears to be gravity environment.
Yeah.
And so that's the theory behind that.
That's the theory behind it. And but you get some gravity out at the circumference, but as you go in towards the center, of course, there's no artificial gravity. So what they're planning is that, well, if you go out halfway, you can do things like have basketball courts, and people can just jump up to the basket and stick it in there.
Three-pointers.
You get 3 pointers all the time.
All the way from the other end.
So they're thinking that entertainment, live entertainment, cooks, and so forth. And so that is going to happen apparently. Probably not on the schedule that we planned. It's going to happen. In fact, there's some fraud already going on with regard to that because there are people. Well, I don't know that it's fraud. I shouldn't say that, but there are people who are saying that if you want to work in space, you can join the work crew by sending us money, and we'll put you on the work crew. Well,
Is it unionized?
it's a good
Well,
question.
we were talking about what kind of labor law would apply to the workers up in space. Yeah.
That's right. Yeah, and I think it's the same labor law that we have here. It's just in a different location and
Yeah.
some different rules and stuff.
Yeah. Well, I like the idea that some like Hilton's already thinking about building this. So it's not just the Richard Bransons or the Elon Musk, but it's now stretching out to corporations that are already in the industry. And all we're trying to do now is put the industry in space around the Earth.
Right, and there are other companies that are planning to do this, not just Hilton, other companies, because the NASA's getting out of that business.
Right.
And also, right now it costs about $3 million to get people up there and back, but they expect that cost to drop dramatically.
Yeah, I'm
with time.
surprised it's still that high because you think after all these years, I mean, the space shuttle and then the subsequent rocket launches, reusable rockets and things like that, just seems to keep the cost dropping. With the idea.
Why
that
isn't it lower?
Yeah, you would think. You would think. I will tell you that what's really interesting is the fact that there's so much interest in getting us there.
Yeah.
And that's the average the average person that can afford it, but the idea that normally we can get out there. But Mark, I think we should come back to this at a different time because I think we barely scratched the surface of this.
There's a lot more.
Yeah, and I wanted to thank you tonight.
It's my pleasure.
Emerson and Mark, of
Good
course.
to see you.
And I'm gonna say that I'm looking forward to that first trip.
Okay.
And I know that your law review prep class set you up for that first trip.
I'm ready to go.
And Mark, we can go on out there. So tonight, as we wind down Law Talk, the show that brings you the Constitution, the events of the day, and the law, brings us to outer space tonight. And I want to thank us all because it was a very stimulating conversation.
Thank you.
Good night.
Okay, good to see you.